So if I start with this problem, this 6x cubed plus 7x squared plus x plus 1 divided by 2x plus 3, that's the same thing as dividing by this guy right here, 2 times x plus 3 halves. So what I'm going to do first is I'm going to divide by this, and then I'm going to divide by 2. So dividing by this is very easy because I can just do synthetic division as negative 3 halves, and then 6, 7, 1, 1, and then just bring this down and just start multiplying. Pause the video and finish that, that synthetic division, and then come back. Okay, so I went ahead and did this, and I ended up with this result. And now I'm going to factor out that 2 by dividing everything by 2 in this result. And if I divide everything by 2, I get 2 times 3x squared minus 2x plus 4. And if I divide that by 2, I get minus 5 over 2x plus 3. And that is exactly what the product or the quotient is up here for the final answer. So if you have a look at this, hopefully that'll become a little bit clearer because I'm really dividing by 2 to factor it out. All right? Okay, and the rational root theorem is basically the way we can make a list of possible factors of any polynomial. So basically, we have p over q, where p is a factor of the constant term, and q is a factor of the leading coefficient. So if we take p divided by q, okay, p over q is some rational number, and it is the simplest form and is a 0. If there is in fact a rational root, it must be in the form of p over q, where p is a factor of the constant term and q is a factor of this. So if I want to list all the possible rational zeros of this example here, number 9, all I need to do is take the factors of 9, which are 1, 3, and 9, and we write those as plus or minus. And then we divide that by the factors of 2, which is plus or minus 1 and plus or minus 2, which means all the possible ways you can divide this are possible rational zeros. It doesn't mean they're rational zeros, it just means they're possible rational zeros. Okay, and that's what the rational root theorem tells us. So it could be 9 halves, it could be negative 9 halves, it could be 3 over 2, it could be negative 3 over 2, it could be 1 over 2, it could be 3 over 1. You can see all these different possibilities, all plus or minus. Okay, so it's all those different combinations. Okay, so we're going to use the rational zero theorem and synthetic division to completely factor 6x, or the next problem. So pause the video and see if you can come up with some possible rational zeros. Use your synthetic division to see which ones work. Give it a shot. After a process, I decided to try some of these zeros to see which way I could go with this, and I went ahead and I said, okay, if I plugged in some possible zeros, I ended up trying a bunch of them, and then I ended up trying negative 2, and sure enough, I got a 0 as a remainder, which means x plus 2 is a factor. Okay, so if I know x plus 2 is a factor, then this is 6x squared minus x minus 1. Now the question is, can this be factored further? And I challenge you to see if you can factor this further. We can do that with synthetic division, or we can do it the old-fashioned way and just factor it. Because once we get to a quadratic, if they're asking you to completely factor something, just factor it the old-fashioned way, and that's the easiest way. Give it a shot, pause the video, and come back. So here's the completely factored version of this. And yes, there are 2 more rational zeros, and we can see easily by this, once we factor these, the 2 other rational zeros are negative 1/3, which matches negative 1 over 3, or 1 over negative 3, however you want to say it. And then this one would be positive 1/2, positive 1/2. Pretty straightforward once you do it once or twice. Get down to a quadratic and you know how to factor those. So the question is, oftentimes they'll give you a 0. You go ahead and synthetically divide it out and get the remaining polynomial and then try and figure it out from there. Sometimes you got to use the brute force method, and I know that's difficult and sort of painful, like here, trying to figure out which one worked. And it took me a while. I didn't just, it didn't just happen by magic, like I paused the video and then it happened 2 seconds later. I actually had to go through this iterative process of trying some of these zeros to see which one worked. I even tried +2, and then +2 as the 0 didn't work. Okay, so when I tried +2, I ended up with like 86 remainder or something over here. So just be patient with it, and you'll be fine. Oh, and by the way, have a great day.